So good morning everyone. Today we are going to start a new lesson related to kinematics. Okay. So in kinematics, what we will discuss here, let me share it with you. So this is the topic that we study today, that is kinematics. And in kinematics, we will discuss what are the topics related to the different dimensions of motions that we will discuss today. Okay. You can see first we will discuss the total topics in this kinematics portion. And in the total kinematics portion, it is divided into rectilinear motion, projectile motion, and relative motion. In rectilinear motion, we are going to study about the introduction to rest and motion. What is rest? What is motion? And a very important concept, that is frame of reference. After this frame of reference concept, we will discuss what is distance and what is displacement. And as soon as we will discuss this distance and displacement concept, we will try to understand what is speed and what is velocity. And parallelly, we will discuss what is acceleration, and we will discuss some of the things related to non-uniform accelerated motion. After that, we will discuss the graphs. Okay, and in the graph, we will discuss what is distance and displacement time graph, speed versus velocity and time graph. This graphs we will discuss in this lesson. Okay, and after that, in projectile portion, we will discuss the various projectile motion starting from the introduction to projectile, then oblique projectile motion, horizontal projectile motion, projectile on moving platform, projectile on an inclined plane, and then we will discuss some of the collisions related to projectile motion. And after this, the last topic in this kinematics portion, we will discuss relative motion. So in relative motion, there are various types of problems associated with this relative motion, like river boat problem, wind aeroplane problem, rain umbrella problem, etc. And then we will discuss the very last important topic in this relative motion, which is called velocity approach or separation, and condition for collision as well, as we will discuss in this relative motion. And we will lastly discuss the minimum distance approach to solve some very good type of problem. Okay, so starting from the mechanics, what is the mechanics? So mechanics, it is the branch of physics which deals with the cause and effect of motion. Particularly, we are dealing with motion here. And in this mechanics part, we will discuss the cause and effect of motion of a particle. What is the cause and what is the effect of the particle's motion? So first of all, we will keep one thing in our mind, that the body should be rigid object. Okay, and it may be deformable bodies also, but in total mechanics portion we will consider the object to be a rigid body. Okay, so what is a rigid body? See, basically, if we discuss, practically rigid body cannot exist. But what is the meaning of rigid body? Suppose if we have a block like this, so if I consider the atoms of this block, so it is assumed that this atoms does not displace from its position when force is applied to it. Okay, if I draw the magnified image of some portion of this body, I can draw here. So suppose this is one atom and this is another atom. So between these two atoms, the distance between them is always fixed. Okay, it will not change when we apply the force. That is the meaning of rigid body. It means, you can say, in rigid body the deformation of the bodies cannot be possible. Okay, it is impossible to deform a rigid body. Okay, in deformation or deformable bodies also, like in fluid mechanics when we discuss, so fluid mechanics bodies are deformable, so that part, deformable body, we will discuss in the fluid mechanics part. Now, mechanics is classified under two streams, namely kinematics and dynamics. Okay. Now, what is kinematics and what is dynamics? So let us discuss first these two topics in mechanics. Okay, so mechanics first portion is kinematics. So here the word kinematics means science of motion, okay, or branch of mechanics which deals with study of motion without going into the cause of the motion. That is, we we will not give our interest to the calculation of force as well as torque or any kind of thing which is giving you a cause to the motion, that we are not interested in. Okay, we are only interested in the motion of the object. So you can say, see, kinematics is coming from a Greek letter word which is kinemia, and it means motion. So you can say in kinematics, what we will discuss. So we will discuss only motion of the body. Okay, we will not give our interest to the force or torque. Okay. Now consider in this second portion, that is dynamics. So it is the branch of mechanics which is concerned with all the causes of the motion. That is, you can say force, torque, okay, etc. that cause the motion of the bodies. So that we will discuss in dynamics. You can say total dynamics is considered of Newton's law of motion, that we will discuss various types of Newton's law of motion, like Newton's first law, second law, and third law. So that part we will discuss in dynamics. And in kinematics, we will only deal with motion of the body. Okay. Now see, before we will discuss kinematics, let us understand some of the basic concept of point mass. Okay. So what is a point mass? When the size of the object is much less in comparison to the distance covered by the object, then the object is considered as a point mass. You can say we have a car and this car is traveling on a straight road. You can say different signals here, green, red, green, and this is one sign board also. So distance here are measured in miles. So you can say the distances are very high as compared to the size of this car. Therefore, in order to analyze the motion of this body, we will consider that this car is behaving like a point mass. Okay. Therefore, we can say dimension of a car are very small as compared to the distance traveled by it. So we can take it as a point mass. Okay. Or you can say for our basic understanding purpose, we will take all the big objects like a small point mass. Okay. After that, we will discuss the concept of a body, rigid body, particle. So, what we can say a body? So, a certain amount of matter limited in all direction and consequently having a finite size, shape, and occupying some definite space is called a body. Okay. What is a rigid body? So a body is said to be rigid if the distance between any pair of its constituent particles remains unchanged. So as I told you, the definition of rigid body, distance between the atoms remains constant throughout the motion, it will never change. That is the rigid body. What is a particle now? So a particle, a small part of matter with zero dimension, okay, which can be described by its mass and position is defined as a particle. Okay, so you can say a very small point object type of system a particle is, and we will discuss its mass only, and position parallelly we will discuss for this particle. Okay. Therefore, you can say a particle has only definite position but no dimension. Okay. So in the problem we are going to discuss that we will consider a body to be a particle for the sake of simplicity. Okay. So most of the times in mechanics we will consider any object as particle, or you can say point mass. Now, so very first thing in this kinematics part, we have to understand what is motion and what is rest. So very easy. What is rest? So an object is said to be in rest if it does not change its position with respect to surrounding, or you can say with respect to its surrounding with the passage of time. Okay. So if a body does not change its position, okay, with respect to what? With respect to the surrounding. If it is not changing its position, so you can say the body is in rest. What is motion? So our body is said to be in motion if its position changes continuously with respect to time, okay, with the surrounding, okay, or with respect to an observer, with the passage of time. You can see in the diagram here, this is x-axis, we have a car, and this car is traveling on the road. So with respect to the surrounding, you can say street light and this signal or signboard. So the position of the car is changing with respect to the surrounding. Therefore, you can say the body is in motion. Simple. So very important thing here to understand that whenever we discuss rest or motion, so we will consider the surrounding as well. Okay. Now, so in order to give the definition of rest and motion, I have taken some example. You can see in the animation here, the screen here, okay, that in everyday life, we see some of the object at rest and other in motion, like flying bird, uh, fish swims, and blood flows through the veins and arteries, and car moves. These are the example of motion. Now, atoms, molecule, planets, star, galaxies, they are always in motion. You can see a Tom and Jerry here. I have drawn here. You can see in the first case, the Tom and Jerry are in motion. How? Because both the position of Tom as well as Jerry is changing with respect to time. But in the right side of the diagram, you can see both Tom and Jerry are not changing its position with respect to each other. So you can say the second case is a case of rest. Okay. So right side is the case of rest and left side is the case of motion, because position is changing and here position is not changing. Now, rest and motion are relative terms. Okay, means if suppose someone is moving, so you can say with respect to some surrounding, it can be rest or it can be motion also. You can see an example of a bus. Okay, so motion is a combined property of the object and the observer. Okay, there is no meaning of rest or motion without the observer. Nothing is in absolute rest or in absolute motion. That we will discuss by understanding the example of this person which is sitting in the bus. So a passenger is in a moving bus. The roadside trees appear to be moving backward. Okay, when the person is looking outside the bus, the trees, the road, and the persons are moving, means the trees, the persons which is outside the bus, this person which is inside, he will observe that those trees and persons are moving in the backward direction. Okay, a person is standing on the road, okay, side precises the bus along with the passenger as moving. So a person which is standing outside the bus, he will observe that the bus as well as the person which is inside the bus are moving in the forward direction. Okay. However, the passenger inside the bus sees his fellow passengers to be at rest. Okay. So this is the meaning of the rest and motion. Therefore, they are relative in nature. If suppose a person which is inside the bus, okay, and he is observing a person which is again inside the bus, so for them both are in rest. But if a person is observing a person which is inside the bus, so he will say that the body is in motion. So you can say the body is actually at rest, he is not moving, actually bus is moving. But relative to the bus, this fat man is in rest. But relative to some other person which is standing in the outside of this bus, so this fat man is in motion. Therefore, you can say rest and motion both are relative to each other. Okay. Next, you see, there is nothing like absolute rest or absolute motion. Okay, because now we will discuss a very important thing. We know that the earth is rotating about its axis as well as it is revolving around the sun. So the stationary object like your classroom, a tree or a lamp post, etc. does not change their position with respect to each other. So that is, we can say that they are at rest. Although earth is in motion, earth is rotating as well as revolving. So to an observer which is situated outside the earth, suppose a person is in some space shuttle. Okay, so with respect to that person who is in space, okay, say in a spaceship or our classroom trees etc would appear to be in motion. Okay, therefore all the motions are relative to each other. Okay, we cannot specify absolute rest or absolute motion. Everything is in relative. There is nothing like absolute motion type of thing available for this rest and motion. Okay, next, to understand the concepts of mechanics, first of all, we have to understand what is a frame of reference. Okay, Einstein has given the concept of frame of reference. What is frame of reference? So you can see we have two situations here. Okay, it is a system. First of all, let us define what is frame of reference. So it is a system to which a set of coordinates are attached or with reference to which observer describes an event. Okay, or you can say it is a coordinate system where observer is there and who will describe the event. So first case, you see this person is standing on the platform. Okay, so that platform will become frame of reference. So what he will observe, he will say that this tree is in rest, or this tree does not changing its position with respect to time. So the person says that the tree will be in rest. Okay, consider the second situation when the person is in the train. Okay, the train is moving. Okay, so the reference of frame now becomes the moving train is the reference of frame. So when now he observed this tree, so he will see that tree is moving in this backward direction. Therefore he will say now that the tree is in motion. So a passenger standing on the platform observes that tree on a platform is at rest, but when the same passenger is in passing away in train through station, so he observed that the tree is in motion. So in both the condition, observer is right, but observation are different because in first situation, observer stands on a platform, whereas in the second situation, so you can say for the first situation, reference of frame is at rest, and in the second situation, observer is moving in train, which is reference of frame in motion. Therefore, for these two situation, you can say the tree is in rest for the first case and tree is in motion for the second case. Okay. Now again, see what is reference of frame in more depth. So what conclusion we can get from this? The frame of reference in the left image are people outside the bus. So frame of reference in the right image are people inside the bus. Okay, so you can say the person observing the motion is known as observer, and the observer for the purpose of investigation must have its own clock to measure time and a point in the space attached with other body as origin and set of coordinate axis. So these two things, the time measured by the clock and the coordinate system, are collectively known as reference of frame. Okay, so this is the total definition of reference of frame. Okay, so you can say reference of frame. This is the total definition of reference of frame. Now consider in case of coordinate axis. Okay, so reference of frame and reference of a point. You can say reference of frame is usually considered at origin, and position of the moving object is given by the coordinate axis XYZ coordinate. To locate the position of this object, we need a reference of frame. A convenient way is to set up a frame of reference is to choose three mutually perpendicular axes, namely X, Y, Z axis, and the coordinates X, Y, and Z of the particle. Then specify the position of the object with respect to that frame. Any one of or more coordinate change with time, so we can say the object is moving with respect to this frame. Okay, so that we will have to first specify for this reference of frame. Okay, now generally when we discuss type of motion, so the type of motion, you can say the motion can be in 1D, one dimension, motion can be in 2D, two dimension, or in 3D or three dimension. What is the meaning of 1D motion, 2D motion, and 3D motion? So first of all, types of reference of frame we have to understand, and then we will discuss the various 1D, 2D, and 3D motion. So first frame is called inertial frame of reference. So when frame of reference, that is observer where he is sitting, is either at rest or in a state of constant velocity, then for those type of frame, it is called inertial frames. It means if the frame is not moving, or if it is moving also, so it will move with constant velocity. So that frame is called inertial frame. What is non-inertial frame of reference? So when frame of reference, that is in the observer is present, it is accelerated motion. So then those type of frame of reference are known as non-inertial frame of reference. Okay. So if the frame of reference is accelerated, so you can say it is a non-inertial reference of frame. So for practical purpose, a frame of reference fixed to Earth can be considered as inertial frame. Okay, strictly speaking, such a frame of reference is not an inertial reference of frame because the motion of Earth around the Sun is accelerated motion due to its orbital and rotational motion. But for our simplicity, we will consider that as a inertial frame. However, due to negligibly small effect of rotation and orbital motion, the motion of the Earth assumed to be uniform, and you can say the frame of reference fixed to it may be regarded as inertial reference of frame. Okay, so as I told you that we will discuss now what is the types of motion. So in 1D, 2D, and 3D. So we discussed already what is one dimensional motion. So motion of a body in a straight line is called one-dimensional motion. Motion of a body in plane is called two-dimensional motion. And motion of the body in space is called three-dimensional motion. So when only one coordinate of the position of the body changes with time, you can say it is one-dimensional motion. Example, moving car on a straight road, body in free fall. When two coordinates of the position of a body changes with time, then it is called two-dimensional motion, like motion of car on circular turn or motion of billiard ball. You can say one polo game is there. Now, when three coordinates are changing with respect to time of a body, so it is called three-dimensional motion, like flying a kite. Okay. Now, motion of flying insect. So these are in three-dimensional motion. So you can see the example motion in 1D. Motion of train, you can say in straight railway track. Object is falling freely under gravity. This is also an example of you can say one-dimensional motion. Now, carom board motion of you can say queen in the carom board, insect crawling on the floor of a room, motion of a horizontal and vertical circle, etc. Motion of planet around the sun, car moving in zigzag paths on the road. So these are the examples of 2D motion. What is 3D motion? You can see there are some kites flying. So birds are flying in the sky, also like kite. Random motion of gas molecule, motion of aeroplane in the space. These are the examples of three-dimensional motion. Okay. So now everyone, I'm ending of this session. Okay, I'm leaving you up to this only, and by next class we will begin our concept from the same thing. Okay, so that's all for today, everyone. Thank you for this class. Okay, next class we will continue the discussion of mechanics in this session. Okay, okay, everyone. Thank you.